This is video 12 for College Algebra. This video is going to be talking about combinations and compositions of functions. So first we're just going to be looking at our basics. All right, so we've got our adding, subtracting, multiplying, and dividing. And this is just what everything looks like and how it might be written. So a lot of times we say f plus g of x. Well, that just translates to f of x plus g of x. Okay, the same with the subtraction. The only thing with subtraction is make sure you distribute the negative sign to the entire g function. Okay, chances are if you get a question wrong like this, you probably forgot to distribute that negative sign. Okay, f times g, remember when there's no sign in between them, that means multiplication. So I'm just multiplying my f and my g function. Okay, and the only other one with division is make sure we have to specify that the denominator cannot equal 0, because that would make our function invalid. So let's actually just jump into 3 examples of different types of combinations. So first we're going to do subtraction, f minus g. So what we're going to do is we're going to take our f function, 2x plus 1, and we're going to subtract our entire g function. Now it's not totally necessary that I put parentheses around my first function, but I like to do it just by principle to help me recognize what I'm going to be doing. And from there, it helps me see a little bit more clearly that, oh, I need to distribute that negative sign to all 3 of these terms. And after I do that, that's when I like to get rid of my parentheses and I just write everything out. All right, and then from that, I can combine any like terms. And actually, with this, the only thing left over is negative x squared. And so that's what f minus g of x. Now, number 2, we're going to be multiplying our f and our g function. So here's a really good example where parentheses are definitely important so that we don't forget when we're distributing everything. We've kind of got a long line of things when we distribute. So we'd have 2x cubed plus 4x squared, and I'm distributing that 2x to everything over in the second parentheses, plus 2x, and now plus x squared plus 2x plus 1. All right, and that simplifies. We can combine a lot of like terms. So we've got 2x cubed plus 5x squared plus 4x plus 1. All right, and then our last one, we're dividing our 2 functions. Now this time we are dividing our g function by our f. So we're going to put our g function on the top of our fraction. And sometimes when we have functions like this, it's always important to check to see if we can factor anything. We do know that x squared plus 2x plus 1 is x plus 1 times x plus 1. But I still wouldn't be able to cancel anything out if I factored my denominator. Nothing would cancel out. So this is actually just going to be our answer. And then we just have to say, well, x cannot equal whatever makes the denominator equal to 0. So we'd have 2x equaling negative 1, x equaling negative 1/2. So I can say x cannot equal negative 1/2. And this whole thing would be our answer. All right, the next part of this is the composition of functions. And a lot of times you might have seen this fog. That O is just a tiny o, but that means composed. And what that means is we're going to plug in this g function into my f. And the biggest thing here is that we work from the inside outwards. Okay, so always work inside out. So let's just get started with an example. We're going to compose g into f. So what this means is f composed of g. And I always kind of like to write it out and expand it like this so that I know exactly what I'm doing. All right, so I'm going to take my g function, 4 minus x squared, and anywhere I see an x in my f function, I'm going to replace it with that. So my f function is x plus 2, so I'm going to say 4 minus x squared plus 2. And from there, I can then simplify. This simplifies to 6 minus x squared. Now we can also just do the same thing, but with numbers. So if I wanted f of g of negative 2, first I'm going to find g of negative 2. So that would be 4 minus negative 2 squared. Okay, and that is 0. And then I'm going to plug 0 into my f function. So I'm going to take f of 0, which would be 0 plus 2. So my answer would be 2. Now, another way that we could do this, because we found this composition right here, I can just go ahead and straight up plug my negative 2 into this, because this is what f of g of 2 is. So I could say 6 minus negative 2 squared. Well, 6 minus 4 is still 2. So if we found that composition of the functions already, you can plug it in already, but if not, this is how you would do it. First do the inside, you get an answer, and then plug that into your other function. All right, and now we're going to do this with a little more complicated functions, because here we're dealing with squares and square roots. So first of all, we want to find f of g of x. So we're going to plug in our g function into our f function. So we would have 9 minus x squared minus 9. Well, when we square a square root, that just gets rid of it altogether. So we'd have 9 minus x squared minus 9. So our answer is negative x squared. But we also have to look at the domain of our functions. So I know the domain of x squared minus 9 is just negative infinity to infinity. Our domain for our g function is a little more particular. All right, this function has to be greater than 0 because it is a square root function. If I'm looking at my graph, that's what it looks like. So I'd undo my square root by squaring, and I would get x squared is greater than or equal to 9. And so x is going to be less than or equal to plus or minus 3. So that means we're looking at our function just between negative 3 and 3. Now, we have to take the most restrictive domain for this new function. We can't take something that only happens between -3 and 3 and say, oh, well, we're actually going to make it all numbers. So we have to keep the most restrictive domain. All right, so this is just composition of and combinations of functions.